On the 3rd of October 2025, at 4 in the morning Martian time, something crossed within 29 million kilometers of the red planet, and every spacecraft humanity had stationed there turned to watch. Not because anyone had asked them to overreact, not because of some leaked transmission or a signal bouncing between worlds. They turned because an object born outside our solar system, moving faster than anything we could hope to catch, was passing closer to Mars than almost any natural visitor in recorded history, and nobody wanted to miss it. This is the story of 3I Atlas, the third confirmed interstellar object ever detected entering our solar system, and what happened when it brushed past Mars in a way that even the scientists tracking it did not fully expect. It began quietly. On the 1st of July 2025, an automated sky survey telescope in Chile, part of the Atlas network built specifically to catch objects that might threaten Earth, flagged a faint smudge of light moving against the background stars in a way that didn't match anything already cataloged. Within days, astronomers confirmed what the early data suggested. This was not a rock loosely bound to our sun. This was not a comet on a returning orbit it had traced 1,000 times before. Its trajectory was hyperbolic, meaning it was not gravitationally bound to the solar system at all. It had come from somewhere else entirely, drifted for who knows how many millions or billions of years through interstellar space, and was now, for a brief window measured in months, passing directly through our neighborhood. Only 2 other objects like this had ever been confirmed. 1I Oumuamua in 2017, whose strange elongated shape and lack of a visible tail sparked years of speculation. 2I Borisov in 2019, which behaved more like a conventional comet. And now 3I Atlas, arriving with a size and composition that would soon make the first 2 look almost ordinary by comparison. What made this third visitor different was not just where it came from, but where it was going. Its path threaded it directly through the inner solar system close enough to Mars that 4 separate space agencies scrambled their orbiters to get a look. NASA repositioned the Mars Reconnaissance Orbiter. China's Tianwen-1 orbiter adjusted its imaging schedule. The United Arab Emirates HOPE orbiter prepared its ultraviolet spectrometer. Europe committed both Mars Express and the ExoMars Trace Gas Orbiter, the same spacecraft built to sniff out trace gases in the Martian atmosphere, now aimed instead at a visitor from another star. For the first time in the history of spaceflight, a fleet of instruments built to study one planet found itself pointed at something that had never touched down on any planet at all, and had no origin anywhere near our sun. Here is where the story stops being simple. Because as 3I Atlas closed in on its nearest approach to Mars, the numbers coming back from telescope observations started to look strange in ways that even seasoned astronomers were reluctant to dismiss. First, there was the matter of its composition. When the James Webb Space Telescope turned its infrared eye toward the object in the weeks leading up to the flyby, it detected something unusual in the gas surrounding the nucleus. The comet was releasing carbon dioxide at a rate far higher than the water vapor typically expected from an object warming as it nears the sun. In most comets, water ice dominates the outgassing. In 3I Atlas, carbon dioxide, and strangest of all, a surge of methane appeared in quantities that made some researchers pause and recheck their instruments. This was not the chemical signature scientists expected from a frozen wanderer that had spent eons in the near absolute zero cold of interstellar space. Then there was its size, and here the story only gets stranger. Preliminary estimates, based on how much sunlight the object reflected and how bright its coma appeared, suggested a nucleus potentially far larger than either of the 2 interstellar objects that came before it, though later refined imaging from the Hubble Space Telescope pulled that estimate down to something less than a kilometer across. Even so, the sheer amount of gas and dust it was venting, enough to form a coma visible across tens of millions of kilometers, raised a question nobody could immediately answer. How does an object that small produce that much outgassing, sustained over months without simply falling apart? And then, closest to home, came the trajectory itself. A team of researchers combing through the precise tracking data from NASA's own Horizon system noticed something that read less like coincidence and more like a puzzle. Between the 9th of October and the 25th of November 2025, 3I Atlas made not 1 but 2 distinct close approaches to Mars's orbital path, the second one drawing within a startlingly tight margin of the planet's own orbit. When researchers calculated the odds of an object arriving from a random direction in interstellar space happening to align this precisely with Mars, not once but twice, the number that came back was less than 2 in a million. 2 in a million. That is the kind of probability that makes scientists choose their words with unusual care, because it sits in an uncomfortable place between almost certainly a coincidence and we cannot yet explain why this happened. This is the moment the story reached the public in a way that few astronomical events do. Harvard astrophysicist Avi Loeb, who had already built a reputation for entertaining the possibility that Oumuamua might have been artificial, began publishing a running list of what he called the 7 anomalies of 3I Atlas. Its unusual approach to geometry, the high carbon dioxide to water ratio, the trajectory alignment with Mars, then later with Venus, then Jupiter, the object's apparent lack of a detectable tail at certain phases when one would be expected, its brightness fluctuations that didn't cleanly match a simple tumbling nucleus. Each anomaly on its own was explainable, a quirky composition here, an unusual geometry there, but stacked together they were enough to make even skeptical scientists admit that this was, at minimum, one of the strangest natural objects ever observed passing through our solar system, and at maximum, worth genuinely rigorous scrutiny before anyone closed the book on what it actually was. It did not help that, in the middle of all this, the United States government entered a shutdown, and NASA's public data releases slowed to a crawl at exactly the moment public curiosity was at its peak. Questions were asked in briefing rooms about whether the president had been informed about the object. A member of the House Committee on Oversight and Accountability referenced the anomalies directly in a televised interview. For a strange handful of weeks in the autumn of 2025, an interstellar comet became not just an astronomical curiosity, but a live topic in front of cameras built for entirely different kinds of news. And the silence from official channels, whether born of bureaucratic delay or genuine caution, only added fuel to a fire that was already burning across social media, where amateur astronomers were stacking raw images from Perseverance rover's own navigation camera, hunting for a faint smudge in the Martian night sky that might be their visitor passing overhead. What actually came back from the professional instruments told a more measured story, though not a boring one. Mars Express and the ExoMars orbiter captured lower resolution imagery and spectroscopic readings of the object's coma as it swept past. The composition data reinforced what Webb had already flagged, an object rich in carbon-based compounds in a way that hinted at formation conditions very different from anything in our own solar system's youth. Possibly, some researchers proposed, hinting at an origin from a much older, much colder region of the galaxy than either of its 2 interstellar predecessors. If that theory holds, 3I Atlas may be older than our Sun itself, a fragment of material older than Earth, older than the planets, drifting for billions of years before its path finally intersected ours for this one brief, closely watched crossing. No maneuvering was ever detected, no propulsion signature, no sudden course correction, no burst of acceleration that couldn't be explained by the ordinary physics of a sublimating comet venting gas unevenly from its surface, a phenomenon well documented in comets far closer to home. As the object passed its point of closest approach to the Sun on the 29th of October, then continued outward past Venus in early November, and toward Earth's own orbital distance by mid-December, its speed and heading tracked precisely with what a natural hyperbolic trajectory would predict. And every institution with eyes on it, from Harvard to the European Space Agency to NASA's own Planetary Defense Coordination Office, converged on the same working conclusion. This was, by every available measurement, an ancient, chemically unusual, remarkably active natural comet, not a directed spacecraft, and not something that had ever made contact with anything, on Mars or anywhere else. The anomalies were real. Their explanation so far remained rooted in extraordinary but natural process, chemistry and geometry stretched to their statistical edges rather than evidence of intent. But here is what nobody can fully close the door on, and it is the reason this story refuses to end quietly. The very same team that calculated that 2 in a million alignment with Mars pointed out something else buried in the orbital mechanics. If 3I Atlas's trajectory truly was shaped by nothing more than the random scattering of material across billions of years of galactic history, then an object arriving on a course this precisely threaded past not one but multiple planetary orbits, Mars, then later a close pass near Venus, then a scheduled Jupiter flyby predicted for March of 2026, represents an event so statistically rare that some researchers now openly ask whether the timing of its discovery, arriving just as our planetary defense networks had matured enough to catch it, was itself simply luck, or something closer to the natural result of countless similar objects having passed through unnoticed for millions of years before anyone built a telescope capable of seeing them. Parker's solar probe kept watching through November, snapping roughly 10 images a day of the comet as it receded from its own record-setting pass near the Sun, each frame slowly building a picture of an object that continued to behave in almost every measurable way, like a comet. And yet the questions Loeb and others raised in October have not gone away, because the full data sets from several of the Mars orbiters, months later, still had not been completely released to the public in the detailed form researchers wanted to independently verify. Partial images, partial spectra. Enough to confirm the object's presence and general behavior, not enough, some argue, to fully rule out every alternative explanation for why its trajectory happened to align so tightly, not once, with Mars's own orbital path. What we are left with, then, is not a story with a clean ending, but a story with a very precise set of open threads. An object older, potentially, than our own sun, carrying a chemical signature unlike anything cataloged before it, threading a path through the inner solar system that statisticians calculate should almost never happen by chance, watched by more spacecraft simultaneously than any comet in human history, and yet showing in every measurement taken so far no sign of anything beyond the physics of ice and rock and sunlight. The scientific consensus, for now, holds firmly on the side of a natural, if extraordinary, interstellar wanderer. But consensus is not the same as certainty, and the astronomers who spent the autumn of 2025 watching 3I Atlas slip past Mars know that the object is not finished with us yet. To understand why a 2 in a million probability matters at all, it helps to understand how astronomers actually think about coincidence. Space is, for the most part, empty. When an object arrives from outside the solar system, its direction of travel is essentially random relative to the plane in which the planets orbit the sun. For that object to then pass unusually close to one planet is rare but not shocking. For it to pass close to that same planet twice, on two separate calculated approaches to its orbital path, within a window of weeks, is the kind of result that, in almost any other branch of science, would trigger a formal call for independent replication before anyone drew conclusions. That is precisely what happened here. Multiple research groups, working from the same publicly available JPL Horizons tracking data, ran their own versions of the calculation. The number held. Less than 2 in a million, conditional on the object's confirmed passage on the 9th of October. Whatever 3I Atlas turns out to be, the geometry of its path past Mars is not something scientists are simply taking on faith. It is written into the tracking data that any astronomer with the right software can pull down and verify for themselves. That transparency cuts both ways. It is exactly why the anomalies could not simply be waved away, and exactly why, eventually, they could be addressed one by one with real data instead of speculation. Consider the missing tail. Early in the object's approach, several observers noted that 3I Atlas appeared to lack the long, sweeping dust tail one would expect from a comet actively venting gas as it neared the sun. For a brief window, that absence fed directly into the idea that this object might not be behaving like a comet at all. But as observations continued through October and into November, the tail did appear, faint but present, exactly where solar radiation pressure and the object's own outgassing predicted it should be. The anomaly wasn't a sign of something artificial. It was a sign that the tail had simply not become bright enough yet to register clearly in the earliest images, a timing issue rather than a physics-breaking one. Comets do not announce themselves on a fixed schedule. They brighten unevenly as their surface warms unevenly, and 3I Atlas, whatever its origin, appears to be no exception. The brightness fluctuations told a similar story once researchers had more data to work with. An irregularly shaped, tumbling nucleus, venting gas from different regions as different faces rotate into sunlight, will naturally brighten and dim in a pattern that looks erratic if you only have a handful of data points. With more observations stacked together from Hubble, from JWST, from the Vera Rubin Observatory's Wide Field Survey camera, the fluctuations resolved into something closer to a rotational period, still being refined, but no longer the kind of unexplained flicker that demands an exotic explanation. Each supposed anomaly, examined in isolation with enough follow-up data, folded back into the range of behavior astronomers have documented before in unusual but entirely natural comets. What made 3I Atlas different was not that any single anomaly was unprecedented. It was that so many of them appeared clustered together on an object large enough, active enough, and well observed enough that nobody could simply dismiss the pattern without checking. This is where the story becomes as much about institutions as it is about the object itself. Planetary defense agencies exist specifically to catch objects like this early, calculate their trajectories precisely, and rule out any possibility of collision long before public concern has a chance to build. In the case of 3I Atlas, that system worked exactly as designed. Within weeks of discovery, its hyperbolic orbit was confirmed. Its closest approaches to every planet in its path were calculated, and at no point did any credible trajectory model put it on a collision course with Earth, Mars, or anything else. The danger, if there ever was one, was never physical. It was the danger of a vacuum in official communication being filled by speculation, amplified by a government shutdown that slowed the normal cadence of public data releases at precisely the moment interest was highest. Scientists who study public trust in institutions have long noted that silence, even routine bureaucratic silence, reads very differently to the public than it does inside the agencies producing it. A delayed data release, born of furloughed staff and paused funding, becomes, in the retelling, something closer to concealment. Nobody at NASA or ESA needed to hide anything. The ordinary friction of government process did enough on its own to fuel a narrative that outpaced the evidence. And yet, stripping away the noise, what remains is still one of the more remarkable natural events of the decade. 3 confirmed interstellar objects have now been detected passing through our solar system, each only a few years apart, a rate that itself tells astronomers something important. If we are finding them this often now, with survey telescopes still relatively young in their operational lives, then interstellar visitors are not the once-in-a-generation rarity scientists once assumed. They may be passing through constantly, unnoticed, until instruments sensitive enough and networks coordinated enough finally caught up to the reality of how much material drifts between the stars. 3I, Atlas in that sense, is less a singular mystery and more a preview, a demonstration of what our current generation of telescopes and orbiters can actually accomplish when a genuine unknown crosses our path, and a hint that the next one, and the one after that, may arrive with even less warning. The chemistry remains the piece least fully explained. An object with a carbon dioxide to water ratio this skewed, producing methane in quantities more typical of an object formed in the frigid outer edges of a planetary disk far colder than anything in our own solar system's history, tells researchers something about where 3I Atlas came from before it ever began its journey toward us. Some have proposed it formed around a star far older than the Sun, in a galactic neighborhood chemically different from our own, carrying a composition that is, in effect, a fossil record of conditions no telescope has ever sampled directly before. If that interpretation holds, the true significance of 3I Atlas was never about Mars at all. It was about what a piece of ancient interstellar material can tell us about the galaxy's deep past, delivered not through radio signals or coded transmissions, but through the much slower, much more patient language of spectroscopy and orbital mechanics, read one data point at a time, by instruments doing exactly what they were built to do. In March of 2026, 3I Atlas is expected to pass near Jupiter, close enough for the same networks of orbiters and ground telescopes that tracked its Mars flyby to take another, closer look, this time with months of prior data already in hand and a far better sense of what to search for. Researchers are already preparing observation campaigns, this time coordinated well in advance rather than assembled in the scramble of a discovery only months old. Whether that encounter resolves the last of the anomalies or simply adds new ones to the list depends entirely on what the instruments record when the moment comes. Some researchers expect confirmation of everything the natural comet model predicts. Others, including Loeb, have said openly that they will not consider the question fully closed until every dataset, every image, every spectrum from every orbiter that watched it pass Mars has been made fully public and independently checked. Until then, the object continues its outward journey, carrying whatever answers it holds back out into the interstellar dark it came from, leaving behind a trail of data still being combed through by researchers who are not yet ready to say the story's over. There is a particular kind of unease that comes not from an object doing something inexplicable, but from an object doing something almost inexplicable, close enough to expected behavior that dismissing it feels premature, close enough to strange that accepting it fully feels premature too. That is the space 3I Atlas occupies. And it is worth sitting with why that space matters so much to the people who study the sky for a living. Astronomy, more than most sciences, deals in patience measured across years, not headlines, measured across news cycles. A single flyby, however dramatic, is rarely enough to settle a question this large. What settles it is repetition, cross-checking, waiting for the next data release, the next observation window, the next chance to test a prediction against reality. The scientists who spent October and November of 2025 tracking 3I Atlas past Mars are, as of now, still in that waiting period, still building the fuller picture one orbiter pass at a time. What makes this particular waiting period different from most is the audience watching it unfold. Past interstellar objects came and went largely within the confines of academic journals and specialist forums. 1I Oumuamua took months to become a household name, and even then, mostly among people already following space news closely. 3I Atlas reached political briefing rooms and cable news segments within weeks of its Mars flyby, not because the underlying science had changed, but because the scale of public interest in the unexplained had grown, and because a Harvard astrophysicist willing to say, this might not be entirely natural, carries a very different kind of reach in the current media environment than it once did. That shift says as much about us, about how information now travels and how quickly speculation can outrun verification, as it does about the comet itself. None of that diminishes what was genuinely, legitimately extraordinary about the encounter. An object from another star system, carrying chemistry unlike anything cataloged before it, threading a statistically improbable path past a planet we have spent half a century trying to understand, watched simultaneously by more instruments than any comet in history, remains one of the great observational achievements of this decade, regardless of how the remaining questions resolve. The fact that we could calculate, to a probability of less than 2 in a million, exactly how unlikely its path was, is itself a demonstration of how far planetary tracking has come. A generation ago, an object like 3I Atlas might have slipped through the inner solar system entirely undetected, its Mars flyby recorded by no one, its chemistry never sampled, its origin forever unknown. Instead, it was caught, tracked, photographed by 4 different national space agencies, and sampled by instruments sensitive enough to detect the faint chemical signature of a world that may have formed before our sun ever ignited. That is the part of the story that tends to get lost beneath the louder question of signals and responses. Nothing was sent, nothing answered. But something arrived, ancient and strange and utterly indifferent to our presence. And for a handful of weeks in the autumn of 2025, every eye humanity had stationed near Mars turned to watch it pass, gathering data that scientists will be studying for years, trying to understand exactly what kind of place and what kind of time produced a wanderer like this one.